A digital filter with input x of k and output y of k is described by the difference equation. Y of k is equal to whatever over here, and then the question is to find the discrete time function of the filter h of z. So basically this is dealing with z transform, and we can go to the table and see there's a z transform table over here on page 201 on your FE handbook, and so we're going to be using that directly and applying it to our function over here. Okay, so we have h of z is equal to y over 6 3 x of k is x of z. We don't have to do anything with that, plus 2. Now xk minus 1, let's see here what we have. Well, they call it x or y or whatever, so it doesn't matter really. So we have z minus 1 yz, z minus 1 yz. So we have here, we're dealing with x's, so it's x minus 1. No, I mean z minus 1 instead. xz, z minus 1, x of z, plus for minus 2, we have minus 2 here. So we have z to the power minus 2, x of z. Now we can put the x of z's together, simplify. Z minus 2, and from here we could multiply everything by z, by, let's see here, by z squared. Yes, to kind of get rid of what we have here, like the negative powers. Okay, so if we multiply both sides by we can, okay, let me see here, okay, well, we can multiply by z squared over z squared, so that's basically like multiplying by 1, so you're not really changing the equation at all. The point making here is that I want to get rid of the negative powers. Okay, so if we let me use a different pen. If you multiply, look at here, if you multiply by z squared over z, that's like multiplying by 1, right? We're not changing anything, and so therefore we have h of z. And of course, if you had like a to the power 4, then we would multiply by z to the 4, divide by z to the 4. So this is 1, so you're not changing anything at all. That's the point. Okay, so we have x of z. Then we have 3z squared plus 2z plus 1 over z squared. You're more likely to see this in your response. Oh, okay, yeah, that's, I kind of figured that. I'm sorry. This is supposed to be y of z, of course, and then you divide by x of z, which will give you the filter h of z. That's what it is. So this is y of z. Of course it's y of z. Oh, I'm sorry. This is y of z. So now we can go ahead and divide by x of z. So we have y of z over x of z. This is now h of z, right? And that's equals to 1/6 plus 2z plus 1 over z squared. And that's your response right here. That's it. Now I guess this is straightforward, but the thing is, don't stop here. I guess once you do your simplification, once you do the z transform, don't stop here. You have to go further and multiply by the highest power. So in the FE, the multiple choice questions, you're more likely to see this in the choices than seeing something with a negative sign. So you have to go a little further and multiply out to kind of get your final answer. Because sometimes what happens is you're here and then you look at your 4 multiple choices and you're like, the answer's not there, when you actually have to go a little further. And so you just multiply by 1, whatever the highest power is, and divide by that as well, to get your answer. So that's it. So this is under signal processing, right? Okay. All right. So if you have any questions, again, let me know. I'll put it in the comment section. Thanks.